Hey guys, welcome back to another video. Today we're doing another UKMT question. So the question is this. The diagram shows a shaded shape bounded by circular arcs with the same radius. The centre of three arcs are the vertices of an equilateral triangle. The other three centres are the midpoints of the sides of the triangle. The sides of the triangle have length 2. What is the difference between the area of the shaded shape and the area of the triangle? So to make it easier for us, we'll draw the triangle again. So we have our here, and then we have our 3 semicircles, and then we have our shaded ones that come from here, like that, and then we have our equilateral triangle that runs from the center point of each outer circle. Oh, I already did that. But that's fine. It's okay. Let's draw again. Anyways, so we have that. So to find the area of our... So first we want to find the area of the shaded shapes. So this, to just make it easier, we'll show the shaded. So we have a shaded here. We have shaded here. All the way here. And out from here. And there too. So those are all our shaded shapes. So we have our area of our triangle, which we have to find out first in order to find out the shaded shapes that are in the middle of the triangle. So our area of our triangle would be, so we know it's an equilateral triangle, therefore the side length would be 2. 2 there, and then we can just find its perpendicular height. We can just make that into a right angle triangle, and we know that half of that base would be 1. So we would use Pythagoras theorem to do 2 squared minus 1 squared. So 2 squared minus 1, so 2 squared is 4. 4 minus 1 is 3. So 3 squared, root of that is root 3. So we have the root 3 as our height here. Root 3 as our height, and then we can use our formula half base times height, which is half our base, which we know is 2, times our height, which is root 3. So half times 2 is basically 1. 1 times 3, root 3 is just root 3. So our area of our triangle is root 3. So that we have that there. Now we can find out the areas of our white semicircles in the middle, and then subtract that from the area of our triangle to find out the area of the middle of the red shaded area in the middle. So find the area of our white semicircles. We know we have to prove that the radiuses, so we know, okay, so in our question it says that the circular arcs have the same radius. So if we have a side length of 2, and we have a diameter going across here, and then we have 2 radiuses which are the same on either side, then we have 2 diameters on a side length of 2, so one diameter would have to equal 1, and then a radius would just be half of that, so half would be the radius. So we've proved that the radius is half. So the radius is half, then we can use our pi r squared to find out the area simultaneously of both semicircles to make one circle, and then we just had half of that area to find our third semicircle. So we have half squared times pi to find the area of our 2 semicircles, so our whole circle. So half squared is just a quarter, so you have a quarter pi. Now half of that would be the area of our third semicircle, so we have a half pi divided by 2, which is just 1/8 pi. So you have 1/8 pi. So you have, now we can add both together. So we have a quarter pi, add 1/8 pi, so which is 3/8 pi, because we have 2/8 as a quarter. 2/8 plus 1/8 is 3/8. So you have 3/8 pi as the total area of our white semicircles inside the triangle. So then we can do root 3, which was our area of our triangle, minus 3/8 pi, which equals the area of the shaded stuff in the middle. So we can do root 3 over 1 minus 3/8 pi. To make the same denominator, you would just multiply the root 3 over 1 by 8. So you have 8 root 3 over 8 minus 3 over 8 pi. And then we can just make it easier for ourselves by putting it under the same denominator. So then we just have 8 root 3 minus 3 pi over 8 would be the area of our shaded region in the middle. Now we have our three shaded sectors that are outside of our. So we have our 3 shaded sectors which are on the outside of our equilateral triangle. And to do that, we can use some knowledge that we already know about equilateral triangles. So with equilateral triangles, we know that the angles in an equilateral triangle all are equal. And all angles in a triangle add up to 180 anyway. So we know that each angle would equal 60. So if we know each internal angle equals 60, then each external angle would have to equal 300 to make a full circle. So we know the angle of our exterior, the size of our exterior angle. So we can use the formula of an area of a sector, which is our angle over 360 times by its area, so pi r squared. So our angle in this case is 300. So 300 over 360 times our area, which we know is a quarter pi. Which is, so to simplify it further without using a calculator or anything, we have 30 over 36, dividing both by 10, and then simplifying it further to get 15 over 18, and then simplifying it further to get 5 over 6, but you can't simplify it any further, so you basically have 5 over 6 times a quarter pi, and then you can just easily multiply it across, and then you have 5 over 24 pi. And simplifying it further, you can't simplify it any further to that, so it's just 5 over 24 pi is the area of one sector, so you have to do 5 over 24 pi multiplied by 3 to get all the areas of the total sector area, to get 15 over 24 pi, which then you can also multiply further to divide both by 3 to get 5 over 8 pi. And then you can't simplify that any further. So that's the area of all our shaded sectors on the outside. Now we can add the area of the shaded regions we found inside the equilateral triangle. So then you just do 5 over 8 pi, add our 8 root 3 minus 3 pi over 8. So you can put both under the same denominator. So you just have 8 root 3 minus 3 pi plus 5 pi over 8. Simplifying that further to 8 root 3 plus 2 pi over 8. And then you can separate the numerator and the denominators. So then you have 8 root 3 over 8 plus 2 pi over 8, or 2 over 8 pi, whatever. And then you would get, so 8 and 8 cancel out. So then you just have root 3 plus, and then you can simplify 2/8 further into a quarter pi. So that's our area, the total area of our shaded region. And now the question asks you to find the difference between the area of the shaded region and the area of the equilateral triangle. So then you just do root 3 plus a quarter pi minus our area of our triangle, which we know is root 3. So root 3 and root 3 cancel out, and then you're left with a quarter pi, or in other words, a pi over 4. So that is the answer. Thank you guys for watching our video. Please make sure to like, comment, subscribe, and we'll see you next time. Bye.